What's going on, family? Fat Finger Squad in the building. You got Danny already checking in. Got my phone acting up over here with these damn ads. This phone is so damn slow. I need to get another damn phone. Anywho, what's poppin', family? Today we are doing lab number 40. It's episode number 46. We're approaching our 50th episode of the live streams, also known as the NetworkBruh LiveLabs. But the book is, we are in lab number 57 in the book. I'm sorry. Looks like lab number 58. No, take that back. Lab number 59. Man, we did a lot in this book so far, man. Came a long way, man. Not really. Yeah, we about halfway through the book, as you can see right there. We got Eigrp in the building. We got Pete in the building. What's going on, guys? I'm gonna let a couple of stragglers come in today before I start labeling and cabling. Just to guys let you know already, I already did some cabling. In this case, I only got one cable. As you can see, I have the topology up for y'all to see, right? Notice I've got router 3 and a router 4, or a router 1 and a router 3 there, right? Well, guess what? For this lab, we are not going to use EVE-NG. Sorry to burst your bubble there, Eigrp. I'm not going to use GNS3, and nor am I going to use Packet Tracer. We are going to use some live hardware today. So I actually have some, I have my, what are these? My 2821 routers powered on. I have the serial cable attached, not fully though. Something else I wanted to show y'all too. This is another reason why, because I did a little test run before the stream, and I said, you see, this is the reason why it's better to do it with hardware, because this is something that I was not going to be able. There's a couple things that I noticed. Okay, see, I wouldn't have been able to simulate this with EVE-NG or Packet Tracer or whatever. I mean, I guess you could do it with Packet Tracer, but it's just not the same thing. We're going to let a couple of late stragglers come in. If you guys are using any other packet, you know, any other simulator or emulator, whatever, just kind of get 2 routers, drag and drop them into your topology just like this right here, and then put a serial cable between the 2, right? Just like that. And then we'll get to starting, right? So we got a serial 00 and a serial 00, just like that, right? But I am going to, like I said, I'm going to be using some hardware, right? I'll just give it a couple minutes to let some late stragglers get their labeling and cabling done. As you can see, I already got my labeling here, and then the cabling was just pretty much one physical serial cable, which I've already got kind of plugged in on one side. I just didn't plug it in on the other side just yet, because I wanted to show y'all something with this, right? So, this man is out of here. He's like, man, I ain't watching this stream. I'm out of here, man. Come on, man. Hold on, man. Don't tune off just yet, man. I wanted to show you something. This is something that you would not been able to simulate with any kind of emulator or anything like that, man. This is exactly why I'm glad I have hardware. And I know it's kind of old school, and nowadays, you know, there's all kind of like, you know, ways to virtualize this stuff. But this is just something that I'm glad I have a rack and stuff to kind of play with. Anyways, what else we got on the agenda today? That's pretty much it. This is gonna be the last lab for this week. We're gonna do another lab next week. We're gonna be doing HSRP. So this is gonna be the last Eigrp lab. A lot of acronyms there. In case you are following along for the first time, have you ever used serial DCE and DTE in a real world? That's a very good question, Pete, and I'm glad you asked that. Because obviously serial cables is a slower, it's a slower cabling, right? And a lot of companies obviously are phasing out any kind of serial cables that they have, but you will see it in the real world. Now, physically, having touched like the hardware and being in network closets and stuff like that, data centers, no, I have not seen a serial cable. It wasn't until I bought this physical serial cable right here, which I'll show y'all, on eBay, because I did, you know, all this studying of CCNA and reading about serial cables and all this other stuff. I never knew what a serial cable looked like. So it wasn't until I bought this one on eBay for like $5 or something like that. I got a little 1-footer just like this, and I was like, oh, okay, this is how they look like. They don't actually look like a lightning bolt just like this right here. They're just, you know, they just actually just use that in the network topology just to show you, right? But No, it is not a lightning cable. It is a actual, it's a serial cable just like this right here. That's how it looks like. I don't know if y'all can see that or not, but one side says DCE and the other side says DTE, right? Because one side, remember we said, does the clocking, and the other side is the terminating side. We use this in a lab environment just to simulate the wired area network, because obviously we don't have the internet in our home. We do have our internet in our home, but to simulate the wide area network, this is why we use these back-to-back cables just like this, right? Now, when you said do I use it in the real world? Like I said, physically, no, I have not. But when I worked in the network operations center, we logged into these devices, right? And looked at logs and stuff like that, run show commands. We didn't really do much configuring. But when we're looking at the interfaces, as we're remoted into the devices, yes, I did see a lot of customers that still had serial cables in them, right? And a lot of times they were connected to their ISP using serial cables. But now as a network engineer and, having to work in the data center and having to, go to these network closets on the campus and stuff like that, no, I am not seeing serial cables like this, right? So this is why I said it's a good question. He says it looks like a VGA. You're right. It does look like a VGA cable. In case you guys don't know, VGA cable is a cable that you use for a monitor and stuff like that. But yes, it does look like a VGA cable. Very good point there, man. And like I said, I'd never seen how it looked like, and I just actually bought one because I was curious and I wanted to see how it worked and stuff like that. And when I was doing some cabling, and I was like, why is this not working? And then I looked on the tab of this cable right here. Something else you would not be able to, simulate in EVE-NG or GNS3. When I did the test lab, it was not working, and it was not even noticing the cable. And I was realizing, oh, you know what? You can put it in like this, and you could also put it in like this. It fits both ways, but it's only going to work on one side. There's even a sticker right here. It even tells you, they're not supposed to mismatch like that. And on the other side, there's a notice. It says, notice, ensure the connector is the proper orientation before attaching to Cisco router. Router will not function properly if cable connection is incorrect. Now, will you get a question like this on a CCNA exam? Probably not. But this is just one of those real life things that you can't, like I said, simulate on an emulator or a simulator or anything like that. And this is just some knowledge that I'm just gonna have that maybe a newbie might not have. But I consider myself a newbie, but I wouldn't say I'm seasoned as somebody that probably used to deal with this, decades ago daily. But now I'm having that experience in my home lab. But, so maybe it may be an advantage. It may not be an advantage. But like I said, they probably not going to ask you any kind of question like, why is the serial cable not working? Oh, because you got to make sure that they fit on both sides. You're probably not going to get a question like that on CCNA exam. But, they'll ask you maybe some questions about clocking or DCE versus DTE side, etc. Right? We're about 8 minutes in. Like I said, I'm just getting a couple people to straggle in and stuff like that. But yeah, that's pretty much it. I guess we can get started. For this lab, like I said, I'm consoled in. I have my terminal server right here. Don't worry about that guy. We're just gonna worry about. I have them labeled as router 3 and router 4. So let's just say this guy is gonna be router 3. Right, and then that guy's gonna be router 4 for me. Now yours might be different, but that is what I have them labeled as, because that's how I have them on this rack and stuff like that. And I didn't feel like changing it and stuff like that. I could change it if I really wanted to right now. Matter of fact, let's just do that for now. Because I could always rewrite and reload, and then I'll be good to go. So I'm gonna change this host name to R1, and then the other guy's gonna be R3. But I'm going to reload, and then I won't have to worry about that. So I gotta make sure I don't save. Configure terminal, and he's gonna be R3, right? Sorry, R3. Anybody got any questions or anything like that so far? What we had today on the some current events and stuff like that, man. Paul Pierce got fired from ESPN. Sorry for Paul Pierce. Now that's kind of messed up, man. They basically fired him, man, because he was he had a racy video on Instagram live. He was at a party basically, and a bunch of strippers were twerking, and one of them was giving a massage. They smoking and drinking and stuff like that. I didn't see anything wrong with it, but the man was, he's a married man. It was his son's birthday apparently and stuff like that. And it just wasn't a good look, man. But at the end of the day, he was just, he was just having fun. It was just a regular day. I didn't say a regular day, but he was just chilling, man. It wasn't like he was raping anybody or something crazy like that. It was just, he was just chilling as a man, you know. And but I guess like I said, he has an image to uphold, especially being that he's on TV. He is a married man, you know. He's a father and things like that. And you know, you just hold yourself to some different standards when you are on TV like that. So it's kind of messed up. Y'all ain't gonna see me. Hopefully y'all don't catch me on some Instagram live, you know, with some girls twerking and stuff like that. You know, it was just kind of messed up, man. But anyways, he got fired from that. That was kind of messed up. So let's go ahead and get started. If you guys want to follow along, make sure to get you a copy of this book right here, 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. It's authored by Paul Browning, co-authored by Farad Tafa. Experts agree that we retain only 10% of what we read, but 90% of what we do. And that's why I love this book, because it gives us to practice the theory hands-on and stuff like that. And just like it did today was a perfect example, because I was able to see what happened with the cabling and stuff like that. So right now, I've got my router 1 and router 3 right turned on. I'm going to go ahead and plug this cable up, right? And I'm going to make sure that the DCE side is on router 1, as we see right there, right? So let's make sure I do that. Can you guys do that on Even G? Y'all go ahead and get your cabling done on Even G. Oh, right, that's right. You can't cable them up like that, and you won't even be able to tell. So, especially if you don't have any serial interfaces. So, let's get that cabling up right there. Let's see. The CE right here. That's the party I'm hosting after I get my CCNA. You go ahead and do that, Pete, man. I'm gonna celebrate with you, man. Any update? I don't know what's going on with DMX, man. Hopefully, you know, praise up for that man. But y'all know he was strung up on cocaine, man. And that's as we all know, cocaine is a hell of a drug, man. But hopefully he makes it, pulls through. That's just something that's hard to. I don't want to use that pun, but hard to crack, you know, to let go of those, you know. It's just drugs, man. That's why I'm glad I didn't try drugs or anything like that. It's just something you don't want to do, man. But hopefully he pulls through. I don't know what's going on with DMX, man. So I've got the cable plugged up on router 1. Let's go ahead and take a look at what happened. I got him still as related. Oh, I need to make him. He's supposed to be R3. Yes, I did make him R3. Good. So let's go back to. Oh, that's what it was. I need to change these to R3 and R4, R1 and R3. But either way, just remember R1, R3, right? So this is R1 actually and R3. So don't worry about that. Let's take a look at the cabling. Show. What we got going on? Show controllers. Serial 000 is where I got it plugged into. Verify what I got here. And right there, hardware is that's what you want to see. Now, if you don't have it plugged in, right? This is just so y'all can see. Since if y'all ain't got no serial cable or whatever, let me make sure I don't tie these up like this again. That's another thing. You can tie it up just like a VGA cable. But yeah, Pete, I'm gonna be right with you, man. When you get your CCNA, bro, we're gonna have a party just like that, man. Smoking and drinking and stuff, man. Sorry for that dude, man. What else? Johnson & Johnson. They found some issues with that. Yeah. So yeah, his brain function is unchanged. That's kind of messed up, man. But anyways, that's why I'll use TMZ as my source. This is what happens when you have the cable unplugged, right? Obviously, it'll say down, just like this when we do show IP interface brief, right? Show IP interface brief. Obviously, it's going to be admin down, right? So, show controllers, serial 000, and what we got now. We have, right there, no serial cable is attached, right? That's what it says when you don't have it attached. Just to show y'all, right? I know it ain't that big of a deal, but it's just little things like that you know, because I was looking for, I was like, why is this not working? Boom, it's not even recognizing it. Even if you plug it in correctly, or even if you have it plugged in, because you can plug it in like this, or you can plug it in like that. It's, you know, it's not going to detect it unless it's plugged in the correct side up, because they both go in, but it's only going to read with the it just depends on what type of serial cable you have. But the DTE label has to be up. Just like, you know, be pointing up, and then it'll work, right? So that's just, you know, those little synchron, you know, like nuances that you can't really simulate with even G or GNS3 or whatever. But anyways, we have it plugged in, and we run that command again, and we'll see it sees the cable this time, right? So it says hardware is GT, and then right there. This lets us know it's the DTE side of the cable. And y'all remember GNS3, I used to look for all of this, right? And I was like, how come it doesn't let me know whether it's the DTE side or the DCE side? You can't simulate that. You just can't do it. You can put the clock rate command and do all of that, but there's just those little things like that, man. So anyways, task 1 was to do the host names, which we already done. And then they want us to have router 1, since router 1 is the DCE side end of the back-to-back serial connection. Configure router 1, which is this guy right there, to send router 3 clocking information. So have him send clocking to that guy at a rate of 256 kilobits per second. So let's go ahead and do that, right? So we go to that interface, which is interface 00000. 0. Come on, man. Number lock. 0. Clock rate at 256 kilobits per second, just like that, right? Because this actually says bits, right? Clock. It's actually clock rate 256,000, just like that. Y'all let me know if that's whatever simulator you're using. I'm gonna stop making fun of y'all, but whatever simulator or emulator you're using, let me know what if that clock rate command works for y'all and what it does and stuff like that. I mean, I've seen it, you know, because the last couple streams I was using EvenG and GNS3 and stuff like that. But let me know what you guys are using and what it says and does for you. So we did a clock rate command, right? And it should take it just like that. That was the other thing too. When the cable was not in there, this is something else it was doing. Let me show y'all. Let me get rid of that command. I wanted to show y'all this right here, right? Get rid of that, right? You try to put that clock rate in when the cable is not in there, it still took it. There was something else that I wanted to see it do though. There was something else. It still took it. Come on, man. Maybe because there's no shut. Let's see here. Show IP interface brief. Let me stop experimenting. Show run interface serial 000. It took that command that time. Maybe because it's not shut. I don't know. But last time it didn't take that command, and it was something with the cable, and it had to do. But let me not worry about that right now, because like Pete said, am I even gonna use that cable in the damn real world? Just let me know, man. Stop wasting my time with that old ass cable, man. So let's we already got that cable. I mean that interface. Send the clocking, right? We'll go to router 2 in this case, or router 3 in this case, and to show controllers serial 000. And notice he doesn't have the serial cable attached, right? So I'm gonna put the other side, right? So now I'm connecting this side of the cable, right? And make sure that it is plugged up the correct side and it's plugged in correctly. Run that command again. What does he say this time? He still says no serial cable attached, right? So let me make sure. Yep, it's not, because I have the monoprice side pointing up. Now I have the DTE side pointing up. Run that command again, show controllers. And now it's plugged up. And it says that is the DTE side. Y'all remember a couple of video streams back? I was like, why doesn't it say DTE, DCE? Well, guess what? I was using GNS3, which is a emulator. It emulates the real environment. It's not going to be, it just gives you just enough to, learn this stuff. But the actual hardware, it's just nothing it's just nothing like it, man. With what are you accessing to the routers at the same time? I'm using a terminal server. So this guy right here, I have a Cisco 2821 router with a what's called a I forgot what the card is, but there's a card that has, I'll show you what it looks like. It's called an NM32A or something like that. But basically, this guy right here, that's a good question there, Pete. I have this card connected to my 2821 router, right? And then on one of these, notice there's 4 of these card lines here, right? One here, one there, one there, one there, right? Then I have this cable called what's called an octo cable. You plug it up to that side, and it's just like an octopus. It got 8 hands, right? And then I can plug up 8 devices to this terminal server, and I can console into them all at the same time if I really wanted to. But right now, I only got 2 cables. plugged up. The rest of the 6 are plugged up to some other devices. But remember, this lab only called for 2 devices, so that's the other thing too. So that's why I love this hardware, man. And yes, you can simulate, like I said, simulate or emulate it with Packet Tracer, GNS3 or EvenG or whatever the case may be. CML. That's what the new kids are using nowadays. But yes, that's what I'm using. Good question there, Pete. So back to what we were doing here. Task number 1 was to send the clocking, right? So we have router 1 clocking to router 3. Configure the IP addresses, which I'm pretty sure y'all know how to do. And if not, just follow along, right? So router 1, we got to go to that interface right there, 000, and configure that IP address, 172.16.1.1/26, right? So go to global config mode, configure terminal, if I knew how to type, interface serial 000, and his IP address is 172.16.1.1. Oops, Fat Finger Squad in the building. Y'all run me with that like button if y'all like what y'all see so far, man. We do this Monday through Thursday, 8 p.m. Eastern Standard Time. And that last octet right there is 26, so that means it is 128, 192, right? And then we're going to no-shut that bad boy, right? That should bring it up. We show our work with show IP interface brief. Remember, when you are done with your work, verify your work. And then when you're done, verify it again. And after you verify it, run another show command to verify your work again. Notice we did a no-shut and it's still down, down. Y'all know why? This side is still slowing down, right? 000. We put the IP address, right? Let's verify our work with the, that doesn't show us the subnet mask, right? Show IP interface brief does not show us the subnet mask. We got to just show IP interface serial 000. And then we'll see the subnet mask is correct, right? 172.16.1.1. So we did that correctly. We got to do the same thing on this side right here. So I'll go to router 3. Right. I know it says 3 and 4 there. Don't just ignore that. It's just that my, my terminal server is different. So, router. I'm sorry. What am I doing here? Interface serial 000. Yeah, it works in Packet Tracer. Okay, that's cool, man. That's perfect. Yeah, it does work in Packet Tracer, and it's gonna show you a little clock, right? And it says DTE and DCE. So yes, it does kind of simulate, but like I said, until you see that cable and you see how it interacts and stuff like that with the routers and stuff, and what happens when you run show controllers and when it's not plugged up, etc., there's just something about the hardware that's just like, you can't simulate real life, man. I know everything is going to the cloud and everything like that, but guess what? Somewhere there's some physical hardware. So no, your information is not being offloaded to an actual cloud, right? There's a data center somewhere, right? So interface 000, we got to do that IP address. IP address is 172.16.1.2. His subnet mask is same thing, 192, right? We no shut. That's the reason why the other side was not up, because we got to no shut that bad boy, right? No shut. No. Yeah. And we should get a log message letting know it comes up. It comes up. Good, it's up. And let's show our work. Show IP interface brief. I don't care how little it is. Verify your work. So that's all caps. That's the reason why I didn't do it. But now he's up. And I'm pretty sure that subnet mask is correct. But let's do it anyway. Show IP interface serial 000. And he's 172.16.1.2/26. All right, so he's good. Task 2. Oh, we're still on task 1. There's only 4 tasks here. We should be able to wrap this up quickly. I know we're still on task 1, but don't worry about it. Ping between the routers to verify connectivity based on your configuration. So basically, we're going to have router 1 ping router 2, right? Router 3. Just to make sure that it works. So let's go back to router 1 and make sure, and notice we got a message that it's up now. We can verify that. We'll just ping and verify that we got some network connectivity, basic network connectivity, right? Pray to the network gods and hope that we got some connectivity here, and we got a success, right? We got 5 exclamation points. So we good to go. Task 2, configure the loopback interfaces on router 3 as illustrated in the topology. So we got to basically do these loopbacks on router 3, right? So that should be easy enough, right? Go to router 3, which is that guy right there. I know he says 4, but don't worry, he's router 3. I changed him, right? So we got to configure some loopbacks. Y'all know what those are, right? Those are virtual interfaces, right? So loopback 10 with the respective IB addresses, right? 10.10.1.1, 22.1, and 33.1, right? Y'all know how to do that, right? If not, just follow along. IP address 172. I'm so used to typing that 10.10.1.1/24, which is 255.0. He's already up. We ain't got to worry about that. So interface loopback 20. His IP address is 10.20.2.1. And like I said, this is the tedious part, man. Don't worry. Once I'm done with this book, I'm going to leave all of this labeling and cabling and the interfaces, IP addresses. We're going to get past that. So that way we can get to what we need to learn. This is just I'm doing this stuff over and over for some people that don't know how to configure simple stuff like configure an IP address or a host name. That way they know how to do it. And that's how you'll be able to catch on, right? So we got our loopbacks configured. No, we still need to do interface loopback 30. Interface loop 30. His IP address is 10.30.3.1, 255.255.255.0. And let's show IP interface brief to show our work. And we got our loopbacks. We got our physical interfaces up. And these guys we didn't touch those, so we should be good to go, right? Go to router 3. Now, can router 1 see those loopbacks that we just configured on that side, right? Show IP routes, right? You guessed it. No, he can only see what's directly connected to him. This physical cable right here, he can only see those networks right there, which is the 172.16.0.0 network, right? Dot one is me. Dot 2 is the other guy, right? So he can't see these guys because they're not being broadcasted. Well, that's what Eigrp is going to do, right? So dot 3, but shouldn't matter too much. Okay, so what do you say? I don't understand what you're saying. Dot 3. Dot 3 for who? What was you saying? Did I configure somebody incorrectly? 10.10.1.1, 10.22.1, 10.33.1. What you mean dot 3? Who is dot 3? Because he's 1.1 and he's 1.2. Did I do... He's 1.2. Make sure that I did that correctly. He's 1.1. Pete, what did you mean by dot 3? All right, so task number 3. We only got 4 tasks and we're almost done here, y'all. Task 3 was to enable Eigrp ASN 172. All right, so we're going to enable Eigrp on the router with the ASN of 172. Remember what AS3 means, right? Autonomous system. For the routers to be participating in Eigrp, they got to be in the same autonomous system. So it's kind of like in the same room with each other, right? As opposed to OSPF, where the process ID does not have to match. The ASN has to match, right? So let's go to router 1 and configure ASN 172, right? Y'all remember how to do that? If not, just follow along. In case you were tuned in for the first time, this is the book we are using, 101 Labs, Cisco CCNA version 4. You can get a copy of this from 101labs.net. And there's a link in the description box below if you want to get it from Amazon. And it is an affiliate link, which I do get commission from. So that helps out the channel if you get it through my link or whatever. So, and it's a very small commission. It's like I get pennies for it, but it is what it is, you know. Just promoting the book and stuff like that, as if I wrote the damn book. So router 1, we are going to go to global config mode, router Eigrp config mode, or router config mode. And we said the ASN, which is 172, right? 172. And now that we're in router config mode, we are going to do our network statements, right? What is the subnet for this, right? I know it says /26, but guess what? It's still .0, right? Because the magic number for this will let us know that it is 128.64. So it's every 64 networks is the subnet, right? Well, this is 1.1, so the subnet is 1.0, right? Maybe I'll do a video on subnetting or make it easier, because matter of fact, I seen a comment in one of my old videos. Somebody let me know, like, hey man, I love your teaching style, can you do a video on subnetting? And I do need to do that. It's just like I said, I'm studying stuff on my own, but I will get a video to explain something a little bit better and make it a little easier for some people, because like I said, it was just like, this was something I almost gave up on when I was like, I ain't gonna be able to learn this stuff, man. But you got to keep doing it. The more you do it, you'll see patterns and stuff like that, and it starts to become like multiplication tables where you don't even have to think about like 9 times 1 is 81 or 5 times 5 is 25. You just do it so much that you kind of like know the subnet masks and stuff like that. So the network statement again is 172.16.1.0, right? We got to do the same thing on that side, right? On this side, to make sure that they become neighbors and then become happy, just like this, right? That's my happy face for y'all. So we got to go to global config mode and we say router Eigrp 172. network statement, same network statement that'll put them in both. Sorry, net cut out. I meant .1, .2, .3 for the loopbacks, but it doesn't matter. Yes, you're correct. That is correct. I see what you're saying. I'm gonna need you to get a better ISP, man. You got your stuff cutting off and be like, hey man, how's what? Left me hanging there. 17.16.1.0 network, and we should theoretically become neighbors after that, right? Boom. So we got a message, dual, right? Stands for the dual algorithm. This is lets us know it's a level 5 message. I still got to look up what number change means or NBR change means, right? Eigrp, this is the ASN 172. The neighbor is who? This is from router 3's perspective, right? This guy's router 3. He says, oh, I got a neighbor that is 172.16.1.1. That is my new neighbor. That is his IP, his router ID. We learned it through 0.0.0, and we got a new adjacency, right? This is something else I wanted to show y'all that EvenG threw me off yesterday when I was looking for this in EvenG. Indrid, I know if you're still online, let me know if you can see this in EvenG. Right? So we redid, we see we got a neighbor, right? And we can verify that with what? Show IP, Eigrp neighbors, right? Boom. Okay, so we got a neighbor. This is the first neighbor. It starts with a 0. The first one always lets us know it starts with a 0. His neighbor is 172.1.1. That's what we learned. We learned from that guy. The whole timer is 15 seconds, which that's what I meant to cover too. We say hello every 3 seconds on a serial link. And then we consider him dead, I believe, every 15 seconds? Let me see. Yeah. We consider him dead after the 15th second by default. Yeah, so 15 seconds. And Eigrp has been up for 1 minute and 20 seconds. This is a smooth round trip timer. This is the retransmission timeout. So when it times out, we're going to retransmit it every, I believe, 200 milliseconds or something like that. I can't remember. This is the Q count number. Hopefully this stays at 0. Lets us know that Eigrp is working. And the sequence number. This is what I wanted to see. When you run show IP protocols, actually, before we move. Yeah, before I forget. Show IP protocols. Show IP protocols. Come on, man. Maybe I need to type it all out, right? Protocols. And then this was the stuff I was looking for in EvenG, right? I was looking for, 172. Oh, I got another process here. That's what it was. I got to remove that next time. I got to remove that to have a base config. But we're running Eigrp 123. But remember, this is the 172 process. So we do that. And look at that. We got some routing networks that we're routing for that process. Well, guess what? We're not worried about that right now. We came for Eigrp 172. That is our ASN, right? Well, what information we have here? We are redistributing through that ASN. We got our K values. Yes, EvenG did show me that. But guess what? EvenG did not show me. We have our NSF aware route. I got to look up what that is. This is our router ID, since that is our highest loopback address. Oh, look at that. I don't think EvenG showed me this. The active timer, the distance, internal I keep saying that. Our administrative distance for external Eigrp is 170. We have our maximum PABs. We got some hop count. We got some metric variance information. Oh, look, the routing for networks. EvenG was not showing me that the other day. Australia, sorry. It's all good, man. I'm just messing with you, man. We got our routing information sources. Look at this. This is some stuff that I keep saying that. Eigrp was not showing in, yeah, it was EvenG. Was not showing me this in the show IP protocols. It did not let us know whether automatic summarization was disabled or enabled. And the book is telling us right here, we want to ensure in task 3, ensure that Eigrp does not perform automatic summarization at classful network boundaries. That's how it let us know, by running show IP protocols. We did that yesterday with EvenG, and it did not tell us that. We had to actually go to the run show command and see if auto summary or no auto summary was in there. And but if you do show IP protocols on a real device, that's how that'll let you know whether it's enabled or disabled. We wanted to make sure that it was disabled there. So I think that's pretty much it for task 3, right? Enable Eigrp, configure the network statements, but we also have to configure the network statements for the loopback interfaces. So look, let's go back to this guy right here, router 1, and we have to do our new adjacency. Let's take a look at our routing table, right? Show IP route. Even though we are running keep saying that, Eigrp, we don't see any Eigrp routes on here, even though we became an Eigrp neighbor. Why is that? Because The only thing that's being broadcasted out of EIGRP is the 172.16 network. Well, guess what? I already know about that network. Router 1 is already connected to that network. He don't know about the network that sit behind router 3, these loopbacks right here, because they're not being broadcasted, right? So we got to have router 3 broadcast those networks there out of EIGRP, right? So run that show command. We can only see our connected route, right? The connected route is the 1.0 network, this right here. And in our local route, this is basically our interface right there, right? 172.16.1.1. The L is the actual interface that is connected to it, right? That is the connected. So this is the L, that is the C. That's the connected route. This is the local route. It's not really a route, it's really the interface there. So, and it's directly connected. That's why it says /32, because that's the exact number, right? But we wanted to know about these guys, which sit in a 10 network. To have them broadcasted out of there, we got to have router 3 broadcast that, right? So let's go ahead and do that, right? We'll go to router 3, which is that guy right there. Go to global config mode, router EIGRP 172, network, put a network statement of the 10 network should be enough to broadcast that, right? So 10.0.0.0. And now go back to this guy right here and take a look at that router statement. Our routing table, this guy right here, boom, and run show IP route again. And look at that, we got 3 routes there. We got the 10.10 network, 10.22 network, and 10.33 network. We got the D's right here. Remember the D's? D. You got that good D right there, man. D's stand for EIGRP. So we learned these routes through EIGRP. The 90 lets us know it is the administrative distance, right? That is the default administrative distance. Even G can't show that, but even G can show you 20 routers at the same time, and you pay $0 and hear no fans running. I'll give you that. And it's a bit hot in here because I don't have, for one thing, I don't have the AC running. You know how black people do. And also, I am not, what else? Yeah, and I'm using a lot of power here. So yes, I could plug up some more routers. I'm actually buying some more hardware. So I just love hardware, man. That's just how I am, man. I'm a nerd like that. So anyways, now we're seeing those routes, right? And the next task, let me go ahead and wrap this up so y'all can see. But anyways, yeah, that is my terminal. That is the device that we use to console into those devices. Good question there, though, Pete. I know not a lot of people don't need to do this like I'm doing, but I like Eigrp making fun of me and my hardware over here. So task 4 says this is the last task and we're gonna wrap it up. On router 1, verify the state of the received routes in the EIGRP database using the appropriate show commands. Well, we did that with show IP route. We also want to, it says here, to take a more detailed look, also verify the EIGRP database information of the 10.20.20.0 subnet. So he wants us to look at the database for a specific subnet. So remember, we did show IP route, but it gave us all these individual routes right here. It gave us all these routes right here, right? But if we want to take a specific route, we could do show IP route and then that, right? Show IP route. And then look up if you could do a question mark, you'll see what else is going to ask you. We could look up the route like that, or we could just filter it down to just EIP routes, right? Or EIGRP routes. And we'll see just the EIGRP routes just like that. Or if we wanted to just do connected routes, we can do that and just see just the connected routes, included the L's, right? But if we want to look at that specific route, we can put in that route, right? So 10.20.20 network, which he said in the book. I don't know. I think this was a typo too. This is why I'm glad I do test runs now. He wanted to know about that specific database. We do that, it's not going to show up. Let's get rid of this right here. Boom. Subnet is not in the table. Right? I think that was a typo. Let's look up. They wanted us to look up this information, right? 10.22 network. Let's look at that right there. Show IP route that. Right? That is one way we can do it. Show IP route that. And then we have information about that specific route, right? It was known via EIGRP 172. Here's the distance, or administrative distance is 90. This is the metric. We learned about it 3 minutes ago. No, 3 seconds ago. That's the last update, rather. That's the last update. All right, because I believe EIGRP is going to get broadcasted every 3 minutes or whatever. 3 seconds, sorry. That's how long ago we learned it, right? I think. I can't remember. I gotta look that up. We got information on our K values, delay, reliability, the minimum MTU, right? Maximum transmission unit. By default is 1500. We are 1 hop away, etc., 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 right? That is one way to do it. The show IP route and then the actual route you want to know about. But you know what? They wanted us to do the EIGRP database of that, right? So we do show IP, y'all remember that like button, man. Show IP route EIGRP, like that. And then I like to manage devices remotely, and I hate cables, physically devices. I just need a diagram and I'm fine. That's a good point, though. That is a good point, and they say super saver on that AC. Y'all know how we do, man. But that is a good point because 9 times out of 10, believe it or not, when you're a network engineer, you are not going to be seeing the devices that you are configuring, right? So all this stuff I'm doing right here, you're not going to be actually racking into the hardware. You're going to have like technicians and network analysts and field technicians racking and stacking that hardware for you. You as the engineer are just going to be doing the layer 3 stuff, you know, the routing and configuring like we're doing right here, right? So yes, that's a good point. 9 times out of 10, you are not going to see the hardware that you are actually configuring. But it is at least good to know what a serial cable looks like. For the first time, believe it or not, as long as I've had this hardware, this was the first time I actually took a WIC card, took it from, I was like, oh, I could have done this. Because I realized only 2 of my routers, my louder routers, had these serial cards. I actually had to unplug it and plug it up to the other quieter routers and look at and see the serial device and plug up the serial cables there. So, like I said, good point that you might not be able to deal with the cabling and the stacking and stuff like that because 9 times out of 10, as a network engineer, you are not going to see. You are going to be working remotely, and especially nowadays with COVID and stuff like that, you're going to be working from home, configuring these devices. So that's a good point. You might not even be able to touch this stuff, but I like I said, I love doing this stuff, and I like having the hardware and being able to actually see the equipment and see how it interacts with the stuff. So, but anyways, they wanted us to look at the database for that network, show IP, EIGRP, and then what else can you do here? You could actually put the actual ASN number, which we already know about that. We did that, right? And we already did this command, right? Show IP route, and then the ASN number of that. But that's not what we wanted to do. We wanted to do show IP, EIGRP, and then they said the database, right? How can we look at the database? Well, we could look at the database for that network using topology, right? Topology, and then the actual network. So the network to display, the network they were asking us for was the 10/20/20, that one right there, 10/22 network, right? The book, I believe, is a typo, believe it or not. I mean, I think it's a typo because when you put in what they asked for, it's not in there. So you do that, and then there is the information about that network right there. The EIGRP topology entry for it is learned through EIGRP ASN 172. This is the router ID. No, that is my router ID. That is not in the table. Interesting. It's not in the table. So let me put in what they did ask for. 10/20/20 subnet /24. So let's show IP topology that. Let's see. Make sure I completely understand that. Nope, that's not in the table as well. So what if is it because we are not summarizing? Automatic summarization is disabled. I think that's why. Let's see, what is he broadcasting for, right? Let's do this. Show IP EIGRP. We pretty much wrapped it up. We did task 4 already. They just wanted to dissect or look at the EIGRP database a little bit more deeper, right? So show IP, not that EIGRP, I meant protocols. And we are routing for those networks right there, right? Not this guy. That is ASN number 123, which I need to delete. That right there. 10.0 network. Let me get rid of that other network too. I mean, that other routing statement. That's probably why too. No router EIGRP, what is that, 123? Yeah, that's from a previous lab on my hardware. And then show IP protocols. Now he is broadcasting that network. Let's take a look at that over here because it could have been conflicting. Who knows? Let's see. Boom. That's not in the topology. Let's look at the other one, which was 22 network. Topology that. Boom. That's not in the topology table. Yeah, I feel you. It's better to do labs with real devices. Yeah, man. I mean, I ain't gonna say it's better. It's just my preference. You know what I mean? So, it's probably, you know, for some people, maybe they might be on the road more. They might have their laptop and they got GNS3, or they got, you know, a really strong, you know, a good laptop with a good CPU and a lot of RAM, and they could run 50 routers on their laptop. They want to be able to take that to them on vacation and lab while they're on vacation. Guess what? I can't take this rack with me to Cancun unless I ship it out there, right? So it might be more convenient. It's more convenient. Obviously, it's more convenient to have it, you know, installed on your computer, any of those virtual devices and stuff like that. So I am not getting that there. Let me take a look at this. That's another thing. I love this book. Has a solution guide. So let me see what they were really asking for. And I thought I'd seen this before. Task 4 was to run the appropriate show commands to take a look at the database of that subnet. And the way they did that was, we almost done here, y'all. It's pretty much done. We needed to dissect that lab. Some people are software based, some like hardware. Yep, exactly, man. I love hardware, so I am a hardware guy, man. That's why I took coding classes in college, man, and so I was just like, nah, I don't think I want to be a software engineer. I don't like coding and stuff like that. I love hardware, so that is where my passion lies. So, you know, back in the day, I used to break Super Nintendos together and do all of that stuff, man. They wanted us to just do show IP, EIGRT, let me see, this is what it is, 22.0. Oh, you got to put the subnet mask. But you know what I did? I did it in CIDR notation. So 255.0, there you go. That's what I was missing. You got to put in the subnet mask to see it. So the topology entry, we learned it through ASN 172. This is my router ID, right? This is from router 1's perspective, right? Because remember, he's router 1, right? For 22.0 network, this is more information on it, right? State is passive. I believe this is what we want. Because remember, there's different states. There's passive. What are the other ones? Active. If it's an active, it's actively looking for an EIGRP neighbor. We don't want to see that, right? I did a video on that about 2 or 3 years ago. If you want to go on my channel and learn more about that. Query origin flag is 1. I don't know what that is. I got to look that up too. You know, this is why I'm going back to the basics, man. Just looking at these, just doing these little deep dives and, you know, filling the gaps in my knowledge before moving back onto the CCNP. We got our successor route. Remember, successor is the best route. Remember the word success as opposed to FD, which is the feasible distance for it, right? Or feasible successor, which is the backup route, the backup best route. Descriptor blocks. So we got 172.16.1.2. That is this guy right here, right? This is his information he's giving it us to from 16.1.2, so we're learning it from that guy, right? Send flag is 00. Composite metric route is internal. This is an internal route. That is why we have a 90 for the administrative distance, right? Because default for internal routes is 90 is administrative distance. The minimum bandwidth and delay. These are basically the K values, right? Remember we talked about the K values, right? When we do show IP, what's that? Show IP, EIGRP. How you get the K values again? Show IP protocols. Show IP protocols. That gives us our K values, right? That's what that stuff is, right? By default, K1 and K3 are 1. The rest are 0, right? Right. Bandwidth and delay. Those other guys are speed, load, and reliability, right? So back to this right here. Yeah, there you go right there. See? Reliability. That's good when it's 2 out of 5, 255 out of 255. Our load, there's basically no traffic that's on there. Load lets us know how much traffic is on there. Minimum MTU. Hop count is only 1 hop away, right? One hop. So our originating router is that guy right there. So that is the loopback. That's how we learned about that 1020. No, that is our router. So originating router. That is something I need to look at. Why is 1031 the originating router? Anybody know that? Some people. Oh yeah, just look at that. So that's what I need to know. Why is it that the 1022.0 network, the originating router is 1031, right? So we learned about this network, but this is the originating router. Oh no, I need to look that up. What happens if we put 1033 network? Let's do that. Let's do that. This is what labbing is about, man. Let's do 1033 network, right? Because now we're gonna do a deep dive on that network right there, and then we're gonna wrap it up, man. I know y'all tired of me talking right here, and give y'all some time to study 33.1, right? Y'all know when I'm done with this, I kind of like do a little bit of studying, and then you know, then I call it a night and stuff like that. But 33.1, and I hope you guys lab with me Monday through Thursday, 8 p.m. Eastern Standard Time. It's not in the subnet. It is not in our Eigrp table. That's interesting. That is rather interesting. What if we get rid of the subnet mask? That's not in the table either. What if we put oh, it's supposed to be .0 network. Nope, that's not why either. What is that network? Let's do show IP route and take a look. It's that network right there. I want to do a deep dive on that. That's exactly what we put. But when you, oh, subnet mask. We did that, didn't we? There you go. The subnet mask. So now, and then the originating router is also 1033.1. That's what's weird. I need to know what originating router is when you do show IP Eigrp topology. That's weird. That's interesting. Yeah, that's pretty much it, man. If y'all like what y'all see, man, y'all leave a comment down below. Share these videos, man. Let some people know on the Cisco Learning Network. If you're on, you know, Twitter or any other Instagram and stuff like that, just look me up. I'm at NetworkBruh. That is my handle for those. I'm trying to stay off of social media now. I'm trying to like just keep my head on these books and just keep labbing every day. And this is why I love this book, man, because it gives us time to practice this stuff hands-on. You know, doing a deep dive like this right here. .0 network with full network mask. Yeah, so that's what I did right there. Yep. Oh, you said with a full network mask. So let's try that. Yeah, see, I had to put /24 to actually see it. Right? I remember these were the K values. But yeah, maybe I need to do a little bit more information on that and figure out what send flag is and things like that. Do a deep dive on this show command right here. So yeah, that's pretty much it, man. Show IP Eigrp neighbors. What else can we do? Show IP. You know, because this is the last Eigrp lab we're doing in this book, I believe. So let's just get our Eigrp out of our system. Question mark. What else can we do? We did by AS number. We can do accounting. We can do events. What interfaces we're learning out of? Obviously, we're learning it out of that interface, right? Or which ones are participating in Eigrp, right? So we could do interfaces, right? That lets us know 000, right? Just like we said. One peer from that interface. I'm not too sure what the Q unreliable and reliable. I might have to look at. This is transmit Q. I think that's the same thing as RTO. No, that's retransmit. The mean, so this is kind of like, this is almost like the average smooth round trip time right here. And this, I'm not going to pretend I know. Pacing time, unreliable, multicast, flow timer, and pending routes. This is probably like some CCNP or CCIE stuff, man. So if you want to do a deep dive, you got to learn about all this other shit too, man. You know what I mean? So, and that's my ultimate goal. Maybe it might take me a long time, but you know, I'm going to do a deep dive and I'm going to lab every day, and I'm going to y'all just keep streaming with me. And I want you guys to join along before this stuff becomes a little bit, y'all know what the fuck I'm talking about, man. So join along and learn with me, man. So, that's pretty much it, man. That was task 4. What else they said in the book? That's pretty much it. They just wanted us to take a deeper dive at the database information by doing show IP Eigrp topology for those networks. Next lab is lab number 60. Say that 5 times in a row. 60. We're gonna do this on Monday. Implementing HSRP, which is hot standby routing protocol. And I don't know if I'm gonna use my hardware or if I'm gonna use. I think I might use my hardware. You know, it might be a little hot in there. I know Endrick is waiting for me to. He's been, you know, trying to get me to jump on that Eve and G wave. But guess what? I'm gonna buy some more hardware and do some more hardware. And I love doing it this way because I like to explain it and show you the topology just like that. Anyway, so for now, comment, like, subscribe to the network.